Hi there, welcome back to our channel, the hub of DIY electronics project using microcontrollers and some of the most common ICs. If you have been following along in this 555 timer IC video series, then you must be aware that this is our fourth video. We recommend watching our previous videos to grasp more concept about using 555 timer IC. In today's video, we will couple 555 timer IC with CD4017 IC to build an LED chaser circuit to achieve what is playing on your screen right now. We will do a detailed video to explore more about the functionality of CD4017 IC. Briefly, this is a Johnson decade counter with 10 sequential outputs. These outputs become high from 1 to 10 with every clock pulse received, and the cycle continues as long as the IC's clock enable pin is held low. This is the circuit diagram for the LED chaser circuit we will construct today. We will use 555 timer IC to generate clock pulse for the CD4017. As you can see, the 10 LEDs are connected to the IC's 10 outputs through current limiting resistors. We will use the following components: 1 555 timer IC, 1 CD4017 IC, 10 LEDs, 10 270 ohms resistors, 1 220 ohm resistor, 1 1K ohm resistor, 1 470 microfarads electrolytic capacitor, 12 volts DC power source, jumper wires, breadboard. Let's start with the clock pulse generator using 555 timer IC. Place the 555 timer IC on the breadboard as shown. Connect a 220 ohm resistor between pin 8 and pin 7. Connect 1K ohm resistor between pin 7 and pin 6. Connect pin 8 to the positive VCC and pin 1 to ground. Short pin 4 to pin 8. Short pin 6 to pin 2. Place 470 microfarads capacitor between pin 2 and the ground. The clock signal generator is now ready. Let's test it. Connect 330 ohm resistor from output pin 3 to LED and to the ground rail or negative power supply terminal. Observe the polarity of the LED. The longer terminal is always positive and the other negative. And it is working perfectly. The second part of this project is hooking up the LEDs to the CD4017 IC. Place the IC on the breadboard as shown. Next, place the LEDs on the breadboard as shown. The negative terminals touch the ground rail. Add the 270 ohm resistors to each of the positive terminals of the LEDs. Now let's hook up the CD4017 IC to be ready to receive clock signal and give the outputs. Connect pin 16 to the positive voltage and pin 8 to the ground. Connect pin 15, which the reset pin, to the ground. Also, connect pin 13, the clock enable pin, to the ground. Pin 14 will be connected to the clock signal later on. Connect the first output pin 3 of the CD4017 IC to the first LED through the resistor. Do the same for the rest of the outputs and LEDs. Use the picture on your screen as a reference. Power the breadboard to see the circuit in action. You can see the outputs 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, which increases sequentially with every clock pulse received. Let's change the frequency of the clock pulse by replacing the 470 microfarads capacitor with 100 microfarads capacitor. Do you notice how fast the LED moves? Alright, let's reduce the capacitance further to 2.2 microfarads. The clock pulse is now even faster, and you can also see the effect on how fast the LED light moves across the screen. You can also include a potentiometer or a trimmer resistor in place of the 1K ohm resistor to help you adjust the clock frequency on the fly instead of changing the capacitors. Now let's replace the white LEDs with yellow LEDs to see the LED chaser in action better. This was part A of the LED chaser circuit. In our next video, we will do part B to include even more LEDs and an additional CD4017 IC. See you there, and don't forget to subscribe and turn on the notification bell so that you don't miss when the video is out. Also, we will do a video on how to cascade CD4017 IC to achieve even better LED chaser effects. Don't miss that too. Thank you for watching until the end, and have a good day, or rather night, depending on when you are watching this video.